Hi, welcome to this Corbettmaths video. In this video, we're going to look at the video solutions, the area on a grid and the perimeter on a grid practice questions. If you need any extra help on either of those two topics, if you go to corbettmaths.com and scroll down to video numbers 43 and 242, there's dedicated video tutorials there on finding the perimeter on a grid and the area on a grid. Alternatively, you could scan this QR code. But in this video, we're going to focus on the video solutions to the practice questions, so let's get started. So question number one. Question number one says a rectangle is drawn on a centimetre grid below. So we've got this rectangle and it's been drawn on a centimetre grid. That means that each one of these little squares measures 1 centimetre by 1 centimetre. And we've been asked to work out the perimeter of the rectangle. So we want to find the perimeter of this rectangle. So remember, the perimeter is the distance around the outside. So we want to find the distance around the outside of this rectangle. Now, because each one of these squares measures 1 centimetre by 1 centimetre, each of these lines, so joining from here to here, is 1 centimetre. So we can just count. We can go 1, 2, 3, 4, 5. That's going from here to here. That's 5 centimetres. Then 6 going down, 7, 8, 9. And now going across 10, 11, 12, 13, 14. And now going up 15, 16, 17, 18. So the perimeter of that rectangle is 18 centimetres. So let's write that down. The perimeter is 18 centimetres. Now we could have worked it out another way. We could have said, well, from here to here is 5 centimetres, going across from there to there. Going down from here to here, well, that's another 4 centimetres. Going across is 5 centimetres and going up is 4 centimetres. And we could do 5 plus 4 plus 5 plus 4. And that would give you 18 centimetres as well. I tend to just count each one of the little lines going joining from here to here and then there to there and so on, and just count as I go around the shape to find the perimeter. Okay, let's have a look at our next question, part B. So part B says find the area of the rectangle. So because each one of these squares measures 1 centimetre by 1 centimetre, the area would be 1 square centimetre, or 1 centimetre squared. So each one of the squares has got an area of 1 centimetre squared, or 1 square centimetre. So if we want to find the area of this rectangle, all we need to do is count the number of squares inside of it, because each one has got an area of 1 centimetre squared. So if we count the number of them, it would be that many centimetres squared. So let's do that. So it's going to be 1, 2, 3, 4, 5. So it's 5 squares in the top row. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So there's 20 square centimetres, or 20 centimetres squared inside of that shape, so inside that rectangle. So the area of it is 20 centimetres squared. So let's write that down, 20 centimetres squared. And that's it. Okay, let's have a look at our next question. So question number 2. Question number 2 says the diagram shows a shape drawn on a centimetre square grid. So again, a centimetre square grid. So each one of these squares measures 1 centimetre by 1 centimetre. And part A says work out the area of the shaded shape. So we want to find its area. So we need to count the number of squares inside of it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there's 19 squares inside of that shape. Each square has got an area of 1 centimetre squared, so the area of that shape will be 19 centimetres squared. So let's write that down, 19 centimetres squared. And part B says work out the perimeter of the shaded shape. So we want to find its perimeter. So to find the perimeter of the shape, we just need to count the distance around the outside of the shape. So I'm going to start here and I'm going to count each one of the lines going around the shape. So remember, from here to here is 1 centimetre, from here to here is another centimetre, and so on. That'll be 1, 2, 3, 4, 5. So 5 centimetres to go from here down to here. Now going across 6, 7, 8, 9, 10. So we've got to here now. Now let's go up. 11, 12, 13, 14, 15. So we're up to here. Now going across 16, 17. So we're now here. Now going down 18, 19, 20. So we're now here. Now going across 21, 22. So we're now here. Now let's go up 23, 24, 25. So we're now here, and there's one more, 26. So the distance around the outside of that shape is 26 centimetres. So that's its perimeter, 26 centimetres. 26 centimetres. And that's it. Okay, let's have a look at our next question. So question number 3. Question number 3 says Martha draws an octagon on a centimetre grid. So we've got this centimetre grid, so each square is 1 centimetre by 1 centimetre. And we've got this octagon, and part A says work out the area of the octagon. Now this octagon is a bit different than questions 1 and 2, because in questions 1 and 2 we had just whole squares, we could just count the number of squares, whereas here we've got these half squares. There's a half square here and a half square there. Now they will join together to make a whole square, so we can do it that way. We can just join them together to make whole squares, or we can count them as half squares. So what I'm going to do is I'm going to start off, because it's the area, we want to count the number of squares inside of the shape, and each square has got an area of 1 centimeter squared. So I'm going to count the number of whole squares to begin with. So 1, 2, 3. Now going across here, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. And then the whole squares in the bottom row would just be these 3, so 14, 15, 16. So we've got 16 whole squares. Now we've got these half squares, so we could go this one here, 16 and a half, so 16.5 if you wanted to, and then another half, which would be 17, and then another half, which would be 17.5, and then another half would be 18 centimeters squared. So that's one way we could do it, is to count them as half squares and just go to 16 and a half, 17, 17 and a half, 18, and do it like that. And that means the area of this octagon is 18 centimeters squared. So that's one way we could have done it. Or another way we could have done it is, rather than counting up half squares, when we got to 16, we could say, well, we've got to 16 here. We've got these two half squares, so put them together, so that'll be 17, so 17 and 17. And we've got another two half squares, putting them together will make 18 and 18. But either way, you'll get an area of 18 centimeters squared. So the area of that octagon is 18 centimeters squared. And then if we look at part B says draw all the lines of symmetry on the shape. So let's go back up to our octagon, and we want to draw all the lines of symmetry on it. Now what I'm going to do is I'm just going to rub out these numbers so we can see what we're doing. So we want to draw all the lines of symmetry on the shape. So we want to draw all the lines of symmetry on the shape. Now, it's not a regular octagon. If you look at it, obviously the length of this side is not the same as the length of that side. So in terms of the line of symmetry, it's not going to have 8 lines of symmetry. A regular octagon would have 8 lines of symmetry. If we have a look here, we've got a vertical line of symmetry that goes straight down like so. So that's a line of symmetry because it's the same on both sides of that line of symmetry. And then we've got, that's the vertical line of symmetry. We'd also have this horizontal line of symmetry. So the top is the same as the bottom. We can't do the diagonals because it looks a bit like a rectangle. And if you try to fold a rectangle diagonally across, it wouldn't quite fit on itself. So this octagon has 2 lines of symmetry and they look like that. Okay, let's look at our next question, question number 4. So question number 4 says, here's a quadrilateral drawn on a centimetre grid. So we've got this quadrilateral and it looks like a pushed over rectangle. So that's going to be a parallelogram and it's on a centimetre grid. So each one of these squares measures 1 centimetre by 1 centimetre. And part A says, write down the special name for the quadrilateral. So we want the special name of that quadrilateral. As we said, it's a pushed over rectangle. So it's a parallelogram. So let's write that down. It's a parallelogram, parallelogram. Okay, and part B says find the area of the quadrilateral. So we want to find the area of this quadrilateral. Now, there's a couple of different ways we can do this, and I'm going to show you 2 different approaches for this. So it's a quadrilateral, and we want to find its area. So let's count the number of whole squares to begin with. So we've got 1 whole square here. We've got another one, so that's 3. And then we've got this one, which is then going to be 4, 5, and 6. And then at the bottom here, we've got then 7, 8, and 9. So we've got 9 whole squares. Now, if we have a look at these parts, this part and this part will form together. If we put this bit here over here, that would fill up this square. So that would be 10. This bit and this bit would be 10. Then we've got this one and this one. They would form together to make another whole square. So that would be 11. And then this bit and this bit would form together to make another whole square. So that would be 12. So the area of that parallelogram would be 12 centimeters squared. So let's write that down, 12 centimeters squared. So that's one way we could approach that. We could just count the number of whole squares and then join together that one and that one to make 10, that one and that one to make 11, and that one to make 12. So that's one way we could have done it. Alternatively, whenever we had this parallelogram, what we could have done was, we would say if we chop this part off, so chop this part off there, we could have put it on here, and then that would then go there. So if you imagined if you had this parallelogram, a paper parallelogram, it's a bit of a tongue twister, and if you cut it there, you could put this bit onto that bit and it would make a rectangle. So that bit's no longer there, it's moved over to there. So let's count the number of whole squares in this shape. So you'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So if you chop this part off and put it there, you'd have a rectangle and it would have 12 squares. So the area would be 12 centimeters squared, and that's it. Okay, let's look at our next question, question number 5. So question number 5 says, below is a centimetre grid. So we've got the centimetre grid, each square is 1 centimetre by 1 centimetre. And we've been asked to draw a rectangle with a perimeter of 12 centimetres. So we want to draw a rectangle with a perimeter of 12 centimetres. So let's draw a rectangle with a perimeter of 12 centimetres. So remember, that means the distance around the outside of the rectangle is going to be 12 centimetres. So if we start here, we could go 5 centimetres across. 1, 2, 3, 4, 5. So that's 5 centimetres. And then we could go down 1, that'll be 6. That's half of 12, so we're halfway there. So if we go back across, another 5, that'll be 11. And if we got 1, that'll be 12. So that rectangle would have a perimeter of 12 centimetres. And let's just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's a rectangle with a perimeter of 12 centimetres. We could draw another one. For instance, we could go 4 centimetres across and then 2 centimetres down, 4 centimetres across and 2 centimetres up, and that rectangle would have a perimeter of 12 centimetres as well. Let's just check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that would also have a perimeter of 12 centimetres. We could even do like half centimetres and so on, but because it's on a centimetre grid, I would probably stick to those type of rectangles, like a 5 by 1 rectangle or 4 by 2 rectangle. So there's two possible solutions there. Both of those rectangles would have a perimeter of 12 centimetres. So we've done part A, and part B says find the area of the rectangle you've drawn. So let's find the area of both of these rectangles. If you've drawn this one, it would have an area of 1, 2, 3, 4, 5. So the area of this rectangle will be 5 centimetres squared. If you drew a rectangle like this, it would have an area of 1, 2, 3, 4, 5, 6, 7, 8. So the area of that rectangle would be 8 centimetres squared, and so on. So depending on which type of rectangle you drew for part A will depend on what answer you'll get for part B. And there's two possible answers if you drew either that one or that one. Okay, let's have a look at our next question. Okay, so here's question 6. So question 6 says a shaded shape is drawn on a centimetre grid. So again, each one of these squares measures 1 centimetre by 1 centimetre. And part A says work out the area of the shaded shape. So let's just find its area. Let's count the number of squares. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means the area of this shape will be 10 centimetres squared, or 10 square centimetres. Let's write that down, 10 centimetres squared. Okay, and part B says work out the perimeter of the shaded shape. So let's go back up here and let's start with a particular point. I'm going to start here and I'm going to go around the outside of the shape and count the distance around the outside of the shape. And remember, because each one of these squares measures 1 centimetre by 1 centimetre, each one of these lines will be 1 centimetre long. So 1, 2, 3, 4, 5, 6. So we're now down to here. So that's 1 and then another 5 is 6 centimetres. Now going across 7, 8, 9, 10. So we're now here. Going up 1, 11. So we're now here. Going across 12. So we're here. Go up 13. So we're now here. Going across 14, 15. So we're now here. And now going up 16, 17, 18. So the perimeter of this shape is 18 centimetres. So let's write that down. 18 centimetres. And that's it. Okay, let's look at our next question. So question number 7. So question number 7 says, we've been asked on the centimetre grid to draw a rectangle with an area of 12 centimetres squared. So we want to draw a rectangle with an area of 12 centimetres squared. That means we want to draw a rectangle with 12 squares inside of it. Now I'm not going to do 12 in a straight line because we've only got 1, 2, 3, 4, 5, 6, 7, 8 squares across. So I'm thinking maybe 2 rows of 6. So if we do a row of 6, so 3, 4, 5, 6, and then if we go down 2 and then go across and then up, that rectangle should have an area of 12 centimetres squared. And let's just count and check. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area of that rectangle is 12 centimetres squared. We could perhaps do 4 rows of 3. That would work as well. So for instance, we could have done 4 rows of 3. So 4 rows of 3, that would look something like that. You could do 3 rows of 4, or the other way around and so on. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's two possible examples of rectangles with areas of 12 centimetres squared. And then part B says find the perimeter of the rectangle you've drawn. So let's find the perimeter of each of these in case you've drawn one like this or one like this. So for this one, the perimeter, let's start here. So we've got 1, 2, 3, 4, 5, 6 centimetres to get to here, 7, 8 to go down to here, going across 9, 10, 11, 12, 13, 14. We're now here, going up to 15, 16. So the perimeter of this rectangle would be 16 centimeters. In terms of this rectangle, if we started here, we've got 1, 2, 3 going across, 4, 5, 6, 7 going down to here, 8, 9, 10 to get to here, and then going up 11, 12, 13, 14. So the perimeter of this rectangle will be 14 centimeters. And obviously your answer to part B will depend on your answer to part A. And that's it. Okay, so that's question number 7. Let's look at question number 8. Okay, so question number 8 says, here's a centimeter grid. So we've got these set of axes. We've got our x-axis and our y-axis, and this is a centimeter grid. So each of the squares is 1 centimeter by 1 centimeter. And we've been given some coordinates. So P is the point with coordinates 1, 2. Q is the point with coordinates 9, 2, and R is the point with coordinates 9, 11. So let's plot those points. P is 1, 2, so 1 across, 2 up, so that's the point P. And then just going up to make sure we call it the right thing. Q is 9, 2, so let's go 9 across and 2 up, that's Q. And then if we go up, and R is the point with coordinates 9, 11, so let's go 9 across and then 11 up, so going 11 up would bring us to here, so that's the point R. So we've got P, Q and R, so that's the points 1, 2. We've got Q, which is 9, 2, and we've got R, which is 9, 11. And then if we go back up to the question, it says P, Q and R are coordinates of the 3 vertices of a rectangle. So we've got a rectangle and these are 3 of the corners, or 3 of the vertices. And the question says, work out the perimeter of the rectangle and work out the area of the rectangle. So let's draw a rectangle. So if there's 3 of the corners, or 3 of the vertices, P, Q and R, S, the third one's going to be over here somewhere. So that's going to be our last point here, which is 1, 11. So that's the point, our last point, our P, Q, R, S, I'm guessing, will be there. So that is our rectangle. And let's join it up. So we've got our points and let's join them up. So we've got our rectangle, and part A says work out the perimeter of the rectangle. So let's work out the distance around the outside of this rectangle. So let's start here and let's go down. So we've got 1 centimeter, 2, 3, 4,
5, 6, 7, 8,
9 centimeters to get to here. Now going across 10,
11, 12, 13, 14, 15, 16,
17. Now going up 18,
19, 20, 21, 22, 23, 24,
25, 26 centimeters to get to here. Now going across
27, 28, 29, 30, 31, 32,
33 and 34 centimeters. So the perimeter of that rectangle is 34 centimeters. And part B says find the area of the rectangle. So let's find the area of the rectangle. So that's the number of squares inside of it, because remember it's a centimeter grid. So each square has got an area of 1 centimeter squared. So if we count the number of squares, that's its area. So 1, 2, 3, 71 and 72. So the 72 squares inside of that rectangle, so it's got an area of 72 centimeters squared. Or another way you could have done that was to say there's 8 squares in each row, so and there's 1, 2, 3, 4, 5, 6, 7, 8, 9 rows, and 8 times 9 would be 72. So there's 72 squares inside of it, so that's 72 centimeters squared. So let's write that down, 72, and that's it. Okay, let's look at our next question. Okay, so question number 9 says, the diagram shows a shape on a centimeter grid. So again, a centimeter grid. So each square measures 1 centimeter by 1 centimeter. And we've got the shape. And the question says, work out the area of the shape after an enlargement of scale factor 2. So we need to enlarge this shape by scale factor 2. So let's enlarge it. So at the minute, its height is 1, 2, 3, 4. So if we double it, the height will be 8. So 1, 2, 3, 4, 5, 6, 7, 8. So the new shape would have a height of 8 centimeters. The base was 2 centimeters, so we're going to double that. It's going to be 4 centimeters. So 2, 3, 4. This part had a length of 1 centimeter, so let's double it to be 2 centimeters. This part had a length of 1 centimeter, so let's double it to be 2 centimeters. And then we need to go up 3, so doubling it will be 6. 1, 2, 3, 4, 5, 6. That's great. We're in line here. And the length here was 1 centimeter. We're going to double it to be 2 centimeters. So the area of the enlarged shape would be, let's count the number of squares, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the area of this shape was 5 centimeters squared. When we enlarge it by scale factor 2, we're not just going to double the area because we're doubling the heights and the widths and so on. So the area of this enlargement would be 20 centimeters squared. So that's it. So the area is 20 centimeters squared. Okay, let's look at our next question. Okay, let's have a look at our next question, question number 10. So question number 10, part A, we've been asked to draw a right angle triangle with an area of 8 centimeters squared. So we want to draw a triangle, a right angle triangle with an area of 8 centimeters squared. So unlike the rectangles that we looked at previously, we can't just choose 8 centimeters squared. We can't just choose 8 squares and draw a triangle, because with a triangle we're going to have to come across diagonally at some point, so we're not going to have just whole squares inside of it. Now what I'm going to do is I'm going to come down 4 centimeters, 1, 2, 3, 4, and then I'm going to go across 4 centimeters, and then I'm going to go up 4 centimeters, and I'm going to go across 4 centimeters. So what I've drawn there is I've drawn a square, and that square has got an area of 16 centimeters squared, because it's a 4 by 4 square. It's got 4 rows of 4, and 4 times 4 is 16 centimeters squared. Now what I know is that if I chop that square across diagonally, like so if I chop it across diagonally, because the area of the whole thing was 16 centimeters squared, the area of this part would have to be 8 centimeters squared, and the area of this part would have to be 8 centimeters squared. So that means that now if I just rub out this line, so get rid of that line, and that line, that means that this triangle is a right angle triangle, so it's got a right angle here, and it's got an area of 8 centimeters squared. So that's it. That's the right angle triangle that I'm going to draw that's got an area of 8 centimeters squared. Okay, and part B. Part B says draw a scalene triangle on the grid, so we can draw any scalene triangle on the grid. Now remember, a scalene triangle, none of the angles are the same and none of the sides have got the same length, so there's loads of different options you could draw here. I'm going to draw something that looks like this, so I'm going to go across like so, go across to there and go across like that. That would be a scalene triangle. None of those three angles have got the same size, and the three lengths are all different as well. We could draw something a bit different. We could go across like so, and then just go up to a point like that, and a point across like that, and that would be a scalene triangle as well. And as you can see, each of those lines have got different lengths, and each of the angles are different sizes as well. So that would be a possible scalene triangle. That would be one as well. And that's it. So part A is this one. So we've done part A. We've drawn a right angle triangle with an area of 8 centimeters squared, and here we've got two scalene triangles. That triangle is scalene, and that triangle is scalene. And remember, a scalene triangle is just a triangle where the three sides have got different lengths and the three angles are different sizes as well. Okay, so that's it. That's part B. Okay, let's look at our next question, question number 11. So shown are two shapes drawn on a centimeter grid. So again, a centimeter grid, so it measures 1 centimeter by 1 centimeter. I've got shape A and shape B. And the question says, Paul says that the area of shape A is greater than the area of shape B. Is Paul correct? Explain your answer. So let's find the area of shape A and the area of shape B. So let's count the number of squares inside of them. So 1, 18, 19. So the area of shape A is 19 centimeters squared. If we look at shape B, its area is 1, 2, 18, 19. So the area of shape B is 19 centimeters squared as well. And Paul said the area of this shape, shape A, is greater than the area of shape B, but they've both got the same area. They've both got an area of 19 centimeters squared. So let's write that down. Is Paul correct? No. I've written no, they've got the same area of 19 centimeters squared. And let's look at part B. So part B, we've been asked to work out a ratio. I've been asked to work out the ratio of the perimeter to shape A to the perimeter of shape B. So let's find the perimeter of both of those shapes. So let's find the perimeter of shape A and shape B. So let's start off with shape A. So let's count the perimeter. So let's go start here and go all the way around till we get back to where we started from. So counting each 1 centimeter line. 1, 2, 3, 4, 5. Now going down, 6, 7, 8, 9, 10, so we're now here going across, 11, 12, so we're now here going up, 13, 14, so we're now here going across, 15, 16, 17, so we're now here, now going up again, 18, 19, 20. So the perimeter of shape A is 20 centimeters, and shape B, if we start here again and let's go down, 1, 2, 3, 4, 5, 6, 7, 8 centimeters, and we've got to here. Now going across, 9, 10, 11, 12, 13, so we're now here going up, 14, 15, so we're now here going across, 16 would bring us to here, going up, 17 would bring us to here, going across, 18, 19, 20. So we're now here and going up 21, 22, 23, 24, 25. So we're now here and going across the last one, 26. So this shape has got a perimeter of 26 centimeters. So we've got the perimeter of A and the perimeter of B. And we've been asked to write that as a ratio. So that's 20 to 26. And then we can cancel it down. 20 and 26 are both divisible by 2. So that'll be 10 to 13. And that's it. So the perimeter of shape A to the perimeter of shape B would be 10 to 13. And that's it. Okay, let's have a look at our last question, question number 12. So we've got this rectangle A, and it's got a length of 1, 2, 3, 4 centimeters and a width of 3 centimeters. So that's shape A. And we're told that the area of rectangle B, so there's another rectangle B, and the area is 50% larger than the area of rectangle A. So let's find the area of rectangle A to begin with. So the area of this rectangle is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So the area of rectangle A is 12 centimeters squared. And if we go down, we're told that the area of rectangle B is 50% larger than the area of rectangle A, which was 12 centimeters squared. So let's find the area of rectangle B to begin with. So its area is 50% larger. So let's work out 50% of 12. So 50% of 12 centimeters squared is equal to, well, half of it would be 6 centimeters squared. So that's 50% of it. It's 50% larger, so that means we need to add it on. So 12 plus 6 is equal to 18 centimeters squared. So that means we know the area of this rectangle B, it's going to be 18 centimeters squared, because the area of rectangle A is 12 centimeters squared. We're going to increase that by 50%. 50% of it is 6, and adding it on is 18 centimeters squared. We're then told the width of rectangle B is 2 centimeters. So the width of rectangle B is 2 centimeters. Draw rectangle B on the grid. So let's go up, and we want to draw rectangle B on this grid. So we know that its width is 2 centimeters. So let's draw its width to begin with. So it's 2 centimeters. So that's a rectangle, and it's got a width of 2 centimeters. And we want it to have an area of 18 centimeters squared. So that means that we want 18 squares inside of this rectangle. And because it's got 2 rows, that's going to be 2 rows of 9. So let's go 9 across. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got a width of 2 and a length of 9. And let's join it up and draw that rectangle. So there's rectangle B. And let's just check it. It's got a width of 2 centimeters, so 2 centimeters. It's got a length of 9 centimeters. And if we counted the number of squares inside of it, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it would have an area of 18 centimeters squared, and that's rectangle B. And the question said to draw that on the grid. So we've drawn rectangle B. It's got a width of 2 centimeters, a length of 9 centimeters, and it's got an area of 18 centimeters squared, which is 50% larger than rectangle A. And that's it. And that's it. So these have been the video solutions, the area on a grid and the perimeter on a grid practice questions. I really hope you found this video useful. If you need a video tutorial on either of those topics, videos 43 and 242 will give you those video tutorials. But these have been the video solutions to the practice questions, and I hope you found it useful. If you have found it useful, please like it and please subscribe to the YouTube channel. Thank you. Cheers. Bye.